because it was very entertaining. Okay, and a lot of people tweeted and retweeted and did all sorts of things with it. But the truth is that someone simply took the Brexit votes, right, changed the coloring, and put a different date on it, mapped them together, and sent it out. So someone really just made up data. And you might say, well, okay, there's probably some, person in their room just trying to have a bit of fun and came up with a great idea to kind of fool people. So the question is, does that happen in academic circles? Right? You get published papers by respectable institutions. Could it possibly be that they might have incentives to cheat? Could it be? Of course. Now, I don't want you to have this gloomy picture that everyone is cheating around, but there is incentives to cheat, and indeed, there was this one particular very famous case where this very well-known academic really just, because he had a lot of incentives from a pharma company, just made up data to make his case. Like literally just made the data up. And of course he was found and he was banished and all sorts of things, but you should be careful that these things exist. So be very mindful of anyone throwing numbers to you with certainty. So here's my plan for today. 1, I want to talk a little bit about that covariance aspect. Okay? So I want to talk about covariance. And then from covariance, I want to talk about correlation. Because I think it's important, and you will see it a lot in your stat course, this concept of correlation or covariance, and I think you should have it in the back of your head. What is it? We discussed it very briefly yesterday. We're going to try to discuss it in a bit more details. As a warm-up exercise, before we get into the math, I will tell you a story. I'll actually tell you 2 stories. And then I'll tell you about the normal distribution. And then I'll tell you about description, using the tables, table, and finally central limit theorem, which is beautiful. And then I'll talk about hypothesis testing. V100 exercises. And hopefully what I plan to do tomorrow is to do a bit of applications. Right? So tomorrow we'll talk about things like cholera. Right? And for a very long time, cholera was not known whether it was airborne or whether it was waterborne. Right? So it was a statistician that kind of provided evidence from one or the other. So we'll talk a bit about that. And tomorrow I also plan to talk about application of a very, very nice statistical method called regression discontinuity. It sounds very fancy, but it's very simple. It's actually the simplest thing that you can try to draw a causal relationship, right? Because correlations are very easy. Everyone can calculate correlations of stuff, okay? But finding causal things, so building up a model that establishes A cause B, so if A doesn't exist, B doesn't exist. Those are a lot more difficult. So we're going to get to the causal bit and how to get to that causal bit tomorrow. Okay, so today we're still building some muscles. Remember how I started my math revision session with why abstract modeling is useful? Because it allows you to make prediction in very erratic markets. Well, statistical models are also equally useful. Um, I will tell you a story about Ed Thorpe. Anyone knows about Ed Thorpe, Edward Thorpe? No? Well, Ed Thorpe was an MIT professor, and he realized that his salary was not high enough. So he thought he could use his mathematics skills and statistics skills to beat the casinos. So have you heard about the term card counting? He coined it, right? He was one of the first people that did card counting. Card counting came because of that, in many ways. And he went on and beat the casino. He wrote a book, Blackjack, so Beat the Dealer. Right? So he wrote the book on blackjack. Casinos actually started to change the way they dealt blackjack because of him and his friends trying to beat the odds at the casino. So if you think about how a casino works, they have multiple people playing, and the casino has an edge, right? Probabilistically, if you all play over a long period of time, I'm going to win. Okay. And what Ed Thorpe did effectively, he used probability and statistical models to beat the casinos consistently until he was thrown out, beaten, threatened, etc., etc. Right? And eventually, he realized that he could use his statistical knowledge into the stock market, and he went on and